Hi kids, in this video we'll continue with exercise 15.1 from ML Aggarwal class 9, circle, chord properties of circle. We have already done till sum number 10. You can click on the I button and get the video. Now look at sum number 11. An equilateral triangle of side 6 cm is inscribed in a circle. Inscribed in a circle means the vertices of the triangle lies on the circumference. Find the radius of the circle. Very easy. First thing, we'll draw a circle. Now, we'll take an equilateral triangle over here. Suppose A, B, C. Suppose A, B, C is the equilateral triangle inscribed in a circle. Now, the first thing which we should know, that if you drop a perpendicular from A on BC, suppose AM. Now AM is perpendicular on BC. And the most important part is that the center of the circle lies on the perpendicular AB. Suppose this is your center. Okay. Now OM clearly is perpendicular to BC, which means according to the theorem OM bisects BC, which means BM will be equal to MC. And since BC is 6, so this will be 3 cm each. The first thing, look at triangle ABM. In triangle ABM, that's a right angle triangle, which means AM square, if you look carefully, plus BM square is equal to AB square, isn't it? Just substitute the value and get the answer. So AM we don't know, BM is 3 square and this is 6 square. So AM square will be 36 minus 9, that's 27. So AM will be root of 27. Root of 27 can be written as 9 into 3. So root of 9 is 3 and root 3 remains because it doesn't have a pair. So that's AM. We got AM. Now look carefully. I'll join BO. BO is nothing but radius. Look carefully. Similarly, AO is nothing but radius. Now, AM is 3 root 3. So, OM, look carefully, will be 3 root 3 minus AO, that's the radius. So, this we got as 3 root 3 minus R. Now, look at triangle BMO. Triangle BMO. OM square, that's 3 root 3 minus R whole square, plus BM square, that's 3 square, is equal to OB square, that's R square, isn't it? Now A minus B whole square. So 3 root 3 whole square will be 9 3s are 27, plus R square minus 2AB, that's 6 root 3R, plus 3 square is 9 equals to R square. This and this cancels out, which means minus 6 root 3R equals to minus 36, which means root 3R will be 36 by 6 is 6, which means R equals to 6 by root 3. Now we can't leave the answer like this. We need to rationalize. So what we'll do, we'll rationalize. We'll multiply the numerator and the denominator by root 3. This becomes 6 root 3 by 3. So that's radius is 2 root 3 centimeter. Very easy, okay? Drawing the diagram was very important over here, and knowing one fact that the perpendicular from A on BC passes through the center of the circle. Okay? Now let us look at the next sum. Now look at sum number 12. Very interesting. AB is the diameter of a circle. So first, draw a circle with diameter, suppose AB. Okay. M is any point on AB such that AM is 18 centimeter and MB is 8. Suppose M is over here. So AM, this is given to us, is 18 centimeter and MB is 8 centimeter. So without any doubt, AB will add it, that's 26 centimeter, which is the diameter, which means the radius will be 13 centimeter. No doubt in this. Okay. Find the length of the shortest chord through M. So through M, what will be the length of the shortest chord? We need to know that through M, the length of the shortest chord is nothing but a perpendicular through M on AB. So if you draw a perpendicular which passes through M on AB, then this is the length of the shortest chord. We need to find CD. Suppose O is the center. Now the radius AO is 30. No doubt in that. Okay. Then OB is also 30. That's the radius again. MB is 8. Just look at the calculation. So OM will be 13 minus 8. That's 5 centimeter. So this is 5 centimeter. Now join, suppose, CO. Okay. Now look at triangle COM. CO is given as the radius, which is 13 centimeter. OM is nothing but 5 centimeter. So we can say by Pythagoras theorem, CM square plus OM square is equal to CO square. Just substitute the value. So CM is, we don't know CM. OM is 5 square. And this is CO is nothing but the radius, which is 30. So CM square will be 169 minus 25, that's 144. So CM is 12 centimeter. Now look, OM, AB and CD are perpendicular, which means I can say OM is perpendicular on CD. So by the theorem we have OM bisects CD into 2 equal half, which means CM and MD will be same, isn't it? Which means CD is nothing but twice of CM, isn't it? Which is twice of 12, that is 24 centimeter. Which means the length of the shortest chord through M is 24 centimeter. Done. The diagram is very important in this case. Okay, and the small calculation. Now let us look at the next sum. Now look at sum number 13. Very interesting. A rectangle with one side of length 4 centimeter is inscribed in a circle of diameter 5 centimeter. Find the area of the rectangle. Which means, suppose this is your circle, you have a rectangle. Okay, suppose A, B, C, D. Suppose BC is the diagonal and AD is the diagonal. Okay, one side is 4. Suppose the one side of the rectangle is 4 and the diameter of the circle is 5. Now in this case we need to remember that the diameter of the rectangle, the diameter of the circle will be equal to the diagonal of the rectangle, which means this is 5 centimeter and this is 90 degree. We know this. Am I clear? Suppose O is the center over here. The most important point was this. Okay, how this came, I'll make a separate video. Okay, to prove that the diagonal of the rectangle passes through the center of the circle. If the rectangle is inscribed in the circle. Okay, now just look over here. Very easy. Now in triangle CDB, if you look carefully, then BD square plus CD square equals to CB square, isn't it? Which means BD we don't know, plus 4 square equals to 5 square. So BD square is 25 minus 16, that's 9. So BD is 3, okay, centimeter. So the area will be length into breadth, that's 4 into 3, that's 12 centimeter square. Done. The most important part was that the diameter of the circle and the diagonal of the rectangle are same in this case. That is, the diagonal of the rectangle passes through the center of the circle. Okay. Now let's look at the next sum. Now look at sum number 14. Very interesting. The length of the common chords of two intersecting circles is 30 centimeter. If the radii of the circle are 25 centimeter and 17 centimeter, find the distance between the centers, which means suppose we have two circles, okay? This is the common chord, suppose AB. The length of the common chord is given to us as 30 centimeter. Suppose the center over here is O and the center over here is O dash. Okay, then when you join this, okay, we need to know that O dash is perpendicular to AB, the chord. Okay, now they have asked the distance O dash. The radius of the two circles are given as 25 and 70. So OA, suppose this is given as 25 and O dash is given as suppose 17 centimeter. Okay, and the length of AB is 30 centimeter. Now O, suppose this is M. Okay, now look carefully. O dash is perpendicular to AB, which means O dash bisects AB. O dash bisect AB, which means AM will be equal to MB. The entire was 30, so 30 by 2, that's 15 centimeter. So this is 15 centimeter. Now look at triangle AOM, find OM. AMO dash, find MO dash, and then add it. Simple. In triangle AMO, MO square plus AM square, that's 15 square, is equal to AO square, that's 25 square. So MO square will be 625 minus 225, that's 400, which means MO is 20 centimeter. Similarly, if I look at the triangle AMO dash, over there if you look carefully, MO dash whole square plus AM square, that's 15 square, is equal to AO square, AO dash square, that's 17 square. Pythagoras theorem, which means MO dash whole square will be 289 minus 225. That's how much? That's 64. So MO dash will be 8 centimeter, which means OO dash is nothing but 20 plus 8, that's 28 centimeter, which means the distance between the centers of these two circles will be 28 centimeter. The most important part, the common chord is perpendicular to O dash, the line joining the centers. Okay, so it will bisect AB, and then it is Pythagoras theorem. Now let us look at the next sum. Now look at sum number 15. Very interesting. The line joining midpoints of two chords of a circle passing through its center. Okay, prove that the chords are parallel. So we'll take a circle. Suppose there are two chords A, B, and suppose C, D. Okay, suppose M is the midpoint and N is the midpoint over here. So we need to prove that the line joining the midpoint of the two chords of a circle passes through the center. Okay, it passes through the center they have given. Okay, prove that the chords are parallel. Prove that AB is parallel to CD. Now see, OM bisects AB because AM equals to AB, MB they have already given, which means by the theorem OM is perpendicular to AB. No doubt in that, isn't it? Okay, so this is 90 degree. We just got it. Similarly, ON bisects CD. Okay, which means ON will be perpendicular to CD. That was the theorem, the first theorem which we have done. Okay, so this is 90 degree, isn't it? Now look carefully. Angle NMB, is equal to angle MNC. MNC equals to 90 degree. But if you look carefully, this angle and this angle are alternate angle. But they are alternate angle. They are alternate angle. And since they're equal, we can say that AB is parallel to CD. Done. 3 steps. First of all, prove that these two angles are 90 degree. And then by alternate angle property of parallel lines, we can prove that AB and CD are parallel to each other. Done. Now let us look at the next sum. Look at 16. Very interesting. What they have told, if the diameter of a circle is perpendicular to one of the two parallel chords of a circle, prove that it is perpendicular to the other and bisect it. Which means, if we draw a circle, okay, suppose there are two parallel chords A, B and C, D, and we have the diameter, suppose MN, perpendicular to one of the chord. So AB is parallel to CD given, and MN is perpendicular to AB. This is given to us. We need to prove that MN, required to prove MN is perpendicular to CD and MN bisects CD. Okay, that's the question if you look carefully. Very easy. Look over here. MN perpendicular to AB. Suppose this is P, this is Q. Now, since MN is perpendicular to AB, so I'll take, suppose this angle, and suppose QPB, angle QPB is equal to 90 degree. Now, this AB and CD are parallel. AB and CD are parallel, which means angle QPB will be equal to PQC, which is equal to 90, alternate angle property. So if this is 90, this has to be 90, alternate angle. And if this is 90, angle PQC is 90, we can clearly say that MN, which implies MN is perpendicular to CD. Done. Proved. Now, look, OQ is perpendicular to CD. No doubt in that. Which means, according to the theorem, OQ bisects CD. And OQ is a part of MN, which means MN bisects CD. Isn't it? That's the theorem only. Okay, the perpendicular dropped on the chord from the center bisects the chord. Okay, so MN bisects CD, and this is what we were supposed to prove. Done. Now let us look at the next sum. Now look at sum number 17. Very interesting. In an equilateral triangle, I'll take an equilateral triangle first of all. Suppose A, B, C. Prove that the centroid and the circumcenter of the triangle coincide. First of all, what is centroid? The point of intersection of the medians, of the three medians in a triangle. That is centroid. And what a median? Suppose you have a triangle PQR. Suppose the midpoint of QR is K, then PK is known as the median. Median means from the vertex you join the midpoint of the opposite side. Similarly, suppose this is QS is the median and suppose RT is the median. Then the point of intersection of those three median is known as the centroid of the triangle. Am I clear? Similarly, what do you mean by circumcenter? Circumcenter we know. Suppose there is a circle. The vertices of the triangle lies on the circumference of the circle. Then the center of the circle is known as the circumcenter. Now we need to prove that this point and this point coincide, they're same. Very easy. First thing what we'll do, suppose I draw the perpendicular bisector of BC. Then we know the perpendicular bisector of BC, suppose AM. What is AM? AM is perpendicular bisector of BC, and the perpendicular bisector of BC will pass through A, the vertex in this case, because it is a equilateral triangle. Similarly, suppose I draw the perpendicular bisector of AB, then suppose CN. Okay, then CN is the perpendicular bisector of suppose AB. Okay, and they meet at a point O. Just look over here. Okay, now what we'll do, we'll join OB and pass it in such a way that it meets AC at suppose P. Okay, now look carefully. First of all, I'll try to prove that O is the circumcenter. How? Just look over here. Now look at, now AM, just be careful, you know. I've told this in the previous sums also, that suppose there's a line segment, suppose XY, and you draw the perpendicular bisector of this line, then any point on this perpendicular bisector will be equidistant from these 2 points, X and Y. Suppose it is Z, then XZ and ZY will be same. Similarly, look over here, in this case, AM is the perpendicular bisector of BC. So any point on AM will be equidistant from B and C, which means any point on AM will be equidistant, try to understand, equidistant from point B and C, which means simply OB and OC are same. Okay, in the same fashion, look, CN is perpendicular bisector of AB, which means any point on CN will be equidistant from point A and B, which means AO, look carefully, AO and BO will be same. Just now we got OB equals to OC, we got AO equals to BO, which simply means that AO equals to BO equals to OC. So this length OB, OC and OA are same. So with O as a center, if we take OA as the radius, we can draw a circle which passes through the vertices. We can have a circle which passes through these 3 points, isn't it? Which simply means O is the circumcenter. So we got O as a circumcenter. Now since it is a equilateral triangle, now look over here. Okay, look at this triangle AMB and AMC, triangle AMB and triangle ANC. Just look over here. Okay, AM equals to AM, that's common. Okay, just 2 minute patience. Okay, AB equals to AC, AB equals to AC. Okay, that's sides of an equilateral triangle. Okay, then BM equals to MC, BM equals to MC. Why? Because AM was the perpendicular bisector, which means BM equals to MC. So this means triangle AMB is congruent to triangle ANC, which means this angle and this angle are equal, which is 90 degree. So this plus this is, suppose this is x. So x plus x is 180. So 2x is 180. So x is 90 degree. Now x is 90 degree, which means OM is perpendicular to BC, and since OM is perpendicular, it simply means OM should pass through the center, or this line AM, see, which simply means OM is perpendicular to BC. And we have already done in the starting of the theorem that if OM is the perpendicular, okay, the perpendicular on any chord, the perpendicular on any chord of a circle passes through the center, which means AM passes through the center, no doubt in that, through the center of the circle. Is it? Similarly, you can say CN passes through the center. CNAM. What is AM doing? AM is dividing BC into two equal halves. So AM is the median. CN is dividing AB into two halves. So CN is a median. And both the median passes through the same common point O, which means the median, the centroid. This becomes the centroid. O is the centroid as well as the circumcenter. So they both coincide. Is it clear? Just we needed to prove that this median is perpendicular. And when the median is perpendicular, it has to pass through the center. That's the outcome, isn't it? Which I've already explained in one of the video. Okay, if you go through that. So this is the sum. First thing, we need to prove that O is the circumcenter. That is AO, BO and CO are same. So O becomes the circumcenter. Then we need to prove that the medians are perpendicular bisector. Nothing else over here. Which means the perpendicular bisector passes through the center of the circle, which was circumcenter in this case. A little confusion. Don't worry. You need to see the sum. If there's any doubt, pause it and see the sum properly till you get the logic. Okay. Now let us look at the next sum. Now look at this sum, 18 part A, very easy. They have given OD is perpendicular to AB, the chord AB. BC is the diameter of this circle with center O. Show that CA is twice of OD. We have already done midpoint theorem. So this is basically the midpoint theorem sum. What was midpoint theorem? Just remember, we have done over there. Suppose A, B, C. If suppose E is the midpoint of AB, F is the midpoint of AC, E is the midpoint of AB, F is the midpoint of AC, then EF is parallel to BC and EF is half of BC. Remember, this was midpoint theorem, which we have already done. Okay, you can check out the video over there. Look over here. OD is perpendicular to AB. Now, OD is perpendicular to AB, which means OD bisects AB. AB is the chord, which means AD will be equal to DB, which simply means D is the midpoint. D is the midpoint of AB. And O definitely is the center and BC is the diameter, which means O is the midpoint of BC, which by midpoint theorem we can say OD is parallel to AC, midpoint theorem, and OD is half of AC, which means your AC or CA, whatever, will be twice of OD. Done. Pretty easy. Now let us look at the next sum. Now look at 19 part A. I think 18 part B, they have given hint. You can see it and do it easily, okay? In the figure, a line L intersect two concentric circles, which means the center is same, okay? For those two circles at the point A, B, C, D. Prove that AB is equal to CD. Pretty easy. Just drop a perpendicular OM. Draw OM perpendicular to your L, line L. Then for the smaller circle, if you look, isn't it? OM is perpendicular to BC, which means OM bisects BC, which means BM will be equal to MC. No doubt in that. For the bigger circle, again AD is the chord over there. In the previous case, BC was the chord, so AD is the chord, and OM is perpendicular. OM is perpendicular to AD, which means OM bisects AD, which means AM, just look over here, will be equal to MD, isn't it? Now look carefully. AM equals to MD. Instead of AM, can I write AB plus BM? Instead of MD, can I write MC plus CD? Now I think BM and MC is same, okay, which means AB will be equal to CD, and this is what we were supposed to prove. Done. Just the theorem, drop a perpendicular, BM equals to MC, AM equals to MD, split it, and then cut it. You'll get the answer. Cancel these two, which means, okay. Now let us look at the next sum. Now look at this sum, 20 party, very easy. O is the center of this circle, AD is the diameter. There are two chords AB and CD which are parallel to each other given. We need to prove that these two chords are of equal in length, which means AB and CD are equal in length. Very easy. What I'll do, I'll draw a perpendicular OM and ON. Just look over here. And if I can prove that OM and ON are equal in length, then we have a theorem now that chords which are equidistant from the center are equal in length. Now look carefully. Look at these two triangles. First of all, OM perpendicular to CD, ON perpendicular to AB. Now look at triangle OMB and triangle ONA. These two. First of all, OD will be equal to OA. That's the radius. No doubt in that. Then OMD is equal to ONA, 90 degree. Okay. Then this angle and this angle will be equal. Alternate, because these two are parallel lines. AB and CD are parallel. So I can say ODM is equal to OAN, alternate angle, isn't it? Which means clearly triangle OMD is congruent to triangle ONA, angle side. And if these two triangles are equal, we can say that OM is equal to ON CPCT. Now OM and ON, okay, are equal, and these are the length line segment from the center, which means we can simply say by the theorem that chords which are equidistant from the center of the circle are equal in length, which simply means AB is equal to CD. Why? Chords equidistant from the center of the circle are equal in length. We have done this theorem, isn't it? So just prove that the distance from the center of these two chords, that is OM and ON, are equal. Our work is done. Okay. Now let us look at the next. Now look at 20 part B. They given a circle with center O. There are two chords AB and CD which are equal in length, already given in the sum. The two chords meet outside the circle at the point E, we need to prove that AE is equal to CE and BE is equal to DE. Very simple. Just again drop two perpendiculars, suppose OM and ON, on CD and AB respectively. OM perpendicular to CD, which means by the theorem CM will be equal to MD, no doubt. Similarly, ON perpendicular to AB. So ON bisects AB, which means AN will be equal to NB. Now look carefully. CD and AB are equal in length, which means half of the length of these two will be also same. What I mean to say that CM equals to MD will be equal to AN will be equal to NB, isn't it? Because CD and AB are equal. Now, just join OE. Now look at triangle OME and ONE, these two triangles. Look, first of all, OE is equal to OE, that's common, pretty easy. Now, since these two chords are equal in length, which means I can say that OM and ON will be same. Equal chords are at equidistant from the center. Equal chords are at equidistant, isn't it? That's the theorem. And this is 90 degree. OME, angle OME is equal to angle ONE, that's 90 degree. So this is the hypotenuse one side, which means triangle OME is congruent to triangle ONE, and that's RHS. Now once they are congruent, can I say NE? Just look over here. NE is equal to ME CPCD. Now NE, can I write NB plus BE? And ME, can I write MD plus DE? Now MD and NB are same, which means this and this cancels out. So we can say BE equals to DE, isn't it? And then what happens? Add AB on those sides, both the side. We have BE equals to DE. Can I write AB plus BE is equal to AB plus DE? I can add the same quantity on both the side. Okay. Now AB plus BE is nothing but AE, no doubt. Achha, now in this case AB, can I write CD? Because chord are of equal length. CD plus DE. So AE will be equal to CD plus DE is nothing but C. Proved? Clear? Just join OE, prove these two triangles are congruent, and the work is done. So in this video, keep it till here. In the next video, we'll look at some other chapter. Till then, take care.